All right. Hello, and thank you to all the folks who are joining us on time. We're going to give everybody a couple of minutes just to get logged in and settled down. In the meantime, uh, join us in the chat. Tell us where you're calling in from today and say hello. I myself am based in Philadelphia. It is almost like a nice fall day here today, considering the weather we've been having, so that's nice. All right, Tony from Canton, Ohio. Another Tony from Illinois. Go Bills from Steven. I do like Josh Allen, although I'm a Birds fan. All right, give it a few more seconds and then we'll get started. All right, I think we are good to go. So hello, everyone. Thank you for joining us today for Maintenance KPIs That Matter, aligning predictive maintenance with business goals. My name is Adam Creamer. I'm on the marketing team here at AssetWatch, and I'll be your moderator and host for the webinar today. Before we get started, just a couple housekeeping items. First, the webinar will be recorded. You will get that recording after the broadcast today, and you'll get an email about it as well if you want to share that with others. Second, we will be doing Q&A at the end. So you'll see in the chat here, there is a Q&A tab. As questions come up, put them there and we'll get to them once Dustin is done presenting. With that, we'll get started. So we all know in today's competitive environment, maintenance teams aren't just tasked with keeping machines running. They're expected to drive real business value. That's why today's session is really important, and we're aiming to help you connect your maintenance KPIs with the strategic goals that are coming down from corporate. I'm excited to introduce our speaker, Dustin Moore. He's a condition monitoring engineer manager here at AssetWatch. Dustin brings over 2 decades of hands-on experience in maintenance and reliability, from leading predictive maintenance transitions at high volume industries, to mastering vibration and lubrication analysis. He holds ISO Category 3 vibration analyst and Category 1 machinery lubrication analyst certifications, and he has built his career around turning complex asset data into actionable improvement for operations. Dustin is really passionate about empowering maintenance teams with the right information at the right time. And today he's going to be sharing some of his own condition monitoring experience on how you can build out smarter KPIs and move the needle from your business. So with that, Dustin, over to you.
Thank you, Adam. Thank you for the introduction and welcome everyone. I appreciate you taking time out of your busy days to be with us. It's hard sometimes to find that time, so we sure appreciate your attendance. Just a little more detail on my background. I'm from Bowling Green, Kentucky, which is about an hour north of Nashville, Tennessee. As Adam said, I've been involved with equipment reliability for over 25 years. The first 12 years of my career, I worked for an electric motor repair facility, and this is where I built the foundation for my career in predictive maintenance and reliability. In the 12 years that followed, I managed a predictive maintenance program for one of the largest coal producers in the United States, using technologies like vibration analysis, laser alignment, thermography, motor circuit analysis, and others. We were able to shift the company culture from a maintenance standpoint to from a reactive strategy to more proactive and predictive. I've been here with AssetWatch for about 2 years now, and as we go along, we'll speak more to this, but here at AssetWatch, we not only provide continuous monitoring services for your assets, but we also track data that can provide real insights on your team, your culture, and your processes. So today's agenda will be covering which KPIs really matter, how predictive maintenance can help us move the needle, how we can use data-driven insights to drive business decisions. We'll cover some real-world examples And as Adam stated, at the end, we'll do some live Q&A. So why do we need to track KPIs? To me, I feel like KPIs are both like a gauge and like a compass. You can use them as a gauge to kind of see where you are currently, and you can use them as a compass to help you guide where you want to go. Why is it important for us to monitor our tier 1 critical assets? These are the assets that cause the most disruption, and they're the most costly in an event of failure. What's fault resolution time, and why is it important? By measuring how quickly issues are rectified, we can measure our team's effectiveness and identify any bottlenecks in our processes. How quickly does my team respond to alerts? Faster responses reduce downtime risk. They prevent small issues from growing into bigger issues or even failures. What's the time between consecutive faults on the same asset? This metric may help us see that we're just addressing the symptoms of a root cause. Tracking this can show you maybe a troublesome asset or a reoccurring problem. And finally, what types of faults are plaguing my equipment? Are we experiencing the same faults over and over again? So this data may help us prioritize our maintenance actions, target the right training, the right tools, or even upgrades. Am I tracking the right KPIs? So not all KPIs are created equal. Some only show past outcomes. When we think of our traditional reliability metrics, they seem more outcome focused. Forward-looking KPIs can help prioritize smarter actions. Our actionable KPIs, like mean time to comment, mean time to resolution, are more improvement focused. Here we're going to look at some formulas that we use, and I'm not going to go into the math behind each. The math's pretty simple, and it's there for viewing. But we'll talk about what kind of insights we can get out of each one of these, and why they're important. So first, on the top left, mean time to comment there. This is a metric that we track from the time an asset alert is created in the AssetWatch platform, the time between that alert created and the time the customer comments back. So this metric can give us insights on our team's engagement and how quickly they are responding. It could lead to such questions as, are your teams overloaded with other duties and not able to address these issues promptly? Or do we need to work on our culture and mindsets at these sites? Next, below that, we have mean time between faults. This KPI is a good indicator of reliability at the asset level. So are we having repeat issues on the same machine? Are those issues the same every time? And once again, are we fixing symptoms of a deeper root cause? And we'll talk later about some examples of that. Next, mean time to failure, which is somewhat a traditional KPI that you would track, and it's a little bit of outcome oriented, but there are some meaningful things that you can get out of this metric. So if you have certain machines that are failing prematurely or not performing up to their lifespan, this metric can bring that to your attention, and you can consider the reasons behind that. And then finally, we have mean time to resolution, which kind of goes hand in hand with our mean time to comment there. Mean time to resolution is the time between creation of the alert to the time the asset is resolved or the issue is resolved. And at AssetWatch, we use the real data in our trend or our follow-up samples, oil sampling, and communication with our customers to determine if and when those issues are fully resolved. That's in contrast to just using a start and stop date on a work order. So what are we really measuring with reliability KPIs? Traditional reliability metrics such as mean time to repair, uptime, downtime, mean time to failure, and others seem to measure past outcomes. They're more of a reactive view, but we can use data to learn more about our assets and our team and the overall culture of our maintenance programs. This information can help us change the future outcomes. There's a lot of importance in shifting to KPIs that you can influence and not just observe. By tracking these KPIs, we can drive shifts in our maintenance strategies and make sure our teams are fully engaged. We can identify frequent pain points, common faults, or even troublesome assets. As mentioned, traditional metrics focus on what happens after something goes wrong. Metrics like time between failures. So we'd be measuring the uptime in between failures on a machine. Or time to repair, how long it's taken our teams to fix certain issues. Again, they seem to be more focused on reactive tracking rather than proactive prevention. Actionable metrics like time to comment or time to resolve can show us how quickly our teams can react and rectify. In the AssetWatch platform, we have learned that early engagement, that time to first comment, makes a big difference in resolution time. So shorter time to comment equals shorter time to resolve is going to equal fewer catastrophic failures. A quick example of that would be if you correct a lubrication problem in a bearing at that point, instead of letting it evolve into damage on the raceways of the bearing. So that's a much more significant problem if the raceways have actual damage. The biggest highlight here is no response or a delayed response to these issues can lead to bigger failures and higher cost. Predictive maintenance is about shortening the window between fault detection and action. So how does predictive maintenance connect to KPIs? Condition monitoring isn't just about gathering the data. It's about being able to use that data to plan and take actions early. When you use predictive maintenance strategies, you'll find that you have more control and fewer surprises. And speaking of those maintenance strategies, let's compare. You'll see this slide here showing reactive maintenance, preventative maintenance, and prescriptive and predictive maintenance. Let's discuss each one here, starting with reactive maintenance. You can see that the graphic there showing a squiggly line that's all over the place. This is a representation of how chaotic a reactive strategy can be. So a reactive strategy will let machines run until faulty conditions become apparent. Until you're hearing increased noises, you're seeing visible defects, maybe oil leaking from a seal, or you have complete failures. This strategy is by far the most costly, and as mentioned, it is very chaotic. In the middle, we have preventative maintenance, which is a strategy where you are servicing your machines on a schedule. It is better than a reactive strategy, but as we all know, issues are not always linear. Faults or abnormalities can transpire really quickly, and they can fall between your schedules, your routes, or your routines. And then finally, we have the predictive strategy. With the predictive strategy, you're going to use data insights to determine the condition of your machine and take actions based upon those insights. This is where you'll find your highest potential savings, and you'll make sure that your equipment and resources are optimized. The more proactive your strategy, the more KPIs will shift in your favor. Now we're going to look at some real world data. This is pulled from the AssetWatch platform. We're looking at two different facilities here, Facility 1 and Facility 2, but the same parent company. So same company owns both facilities. Processes are close to the same. Assets are close to the same. But as we dig in here, we'll find that there's some stark differences between the two. So the first thing I want to point out is Facility 1 has 86 assets that we're monitoring. Out of those 86 assets, we have 3 that have maintenance recommendations. So that's the highest alert in our software. We have watching where we maybe see some abnormalities, but it gets to a point where we feel like there's some actions that need to be taken. It's considered a maintenance recommended alert. So Facility 1 has 3.5% of their assets in that alert status. Compare that to Facility 2, who has 34 assets total, and 15 of those have that maintenance recommended status. So that's 44%, nearing half of their equipment needs some type of maintenance work. Another thing to point out is in the time with their partnership at AssetWatch, Facility 1 has achieved 45 saves or resolutions. Facility 2 has only 15, which obviously there's some differences in the asset counts. You could expect a little more from Facility 1. But when we dig a little bit deeper down here at these bottom metrics, we look at mean time to comment. Again, that's the time between the alert creation and the response back from the customer side. So it takes Facility 1 an average of 7 days to reply in the AssetWatch software. So they're pretty engaged. Facility 2, it's taken them an average of 75 days to comment back on each alert. As mentioned, mean time to comment goes hand in hand with mean time to resolution. Facility 1 is resolving alerts at an average of 63 days after the creation of the alert, where Facility 2 is taking 157 days to resolve. So this raises some questions. Is Facility 2 under-resourced? Or are they just less engaged? One thing is apparent is issues are stacking up on Facility 2. They're not able to comment back in a timely manner, which is leading to long times to resolve these issues, which shows in the amount of equipment they've got in alert status. So data quality matters. Having the right data can help you make better decisions. We should prioritize based on actual fault trends and not just gut feels or schedules. We want to optimize our schedules to reduce unnecessary PMs and avoid downtime. We want to be able to allocate labor and parts where they're needed the most, and we want to drive continuous improvement. We can do that with trackable KPIs like that mean time to comment, mean time to resolve, or time between faults. So let's connect some dots here, taking some of these insights and turning them into action. Obviously, there was glaring differences in those two sites that we compared on one of the previous slides. So the decision makers at this parent company may want to look at these two sites and try to get an understanding of why Facility 2's metrics are in such contrast to Facility 1's metrics. Another example on the asset level, if we're seeing a low value on mean time between fault, it could tell us that we're treating the symptoms of an issue and not the root cause. And I have a pretty good real world example tied to that one. I had a lumber mill that I was monitoring continuous vibration at, and they had one particular saw that we noticed that this mean time between fault was very low. It was actually around 2 months each time. So during one of our monthly data review meetings, we discussed this. We looked at some case history. It seemed to be a bearing issue every time. So we talked about possible causes, root causes. Obviously, changing the bearing was not addressing. I mean, it's more than wear and tear when you're changing a bearing every 2 months. So we discussed if maybe there could be some clogged grease lines or misalignments within the system. So the maintenance team at the lumber mill went out and done some investigating after our data review, and what they found was they were replacing the bearing itself, the insert, each time, and they were using the existing housing and seal assembly. Once they started looking at this, they found that the seal was out of tolerance. So what was happening was sawdust and debris was contaminating their grease and then working its way into the bearing between the rolling elements and race, resulting in a damaged bearing every couple of months. So they were able to rectify this with new seals that were of proper tolerance. And we're about 6 to 8 months past the correction. So our mean time between faults has a positive increase, and it's still to be determined on just how positive that was, but we definitely, I think we addressed the root cause. Another comparison, real world data here. We're going to be looking at 2 different facilities that have 2 different assets. So here we have facility number 1 and what we'll call asset X. So asset X, we detected a fault on April the 10th. On April the 11th, the customer comments back on that alert, which is a 1-day time to comment. On April the 20th, there was a fix in place that resolved the issue. So in a matter of 10 days, they commented back in 1 day, and they were able to resolve the issue in 10 days. Pretty quick response time. Then we have 108 days time between fault when another fault's detected on August the 6th. And this time, they were even quicker. In a matter of 4 days, they commented back with a resolution, and the issue was resolved on August the 10th. So this shows that fast engagement leads to fast resolution. There is a real value in consistent monitoring in a team that is engaged and ready to respond. Next, we have facility 2, what we'll call asset Y. So at facility 2 on asset Y, AssetWatch detects a fault on December the 30th. It's 111 or 112 days on April the 21st before they comment back with their first comment. 112 days time to comment. It takes 243 days to resolve the issue. So 243 days between the time of the alert and the time there's a fix in place. Almost a year we're working on that alert. And then time between fault, we have only a 21-day window before another fault is detected on September the 19th. So this makes me wonder if the issue was fully resolved from the previous one. But anyway, at the moment of this slide, we were 21 days in on this alert and still waiting for their time to respond back. So compare this to Facility 1's proactive approach, and you can see some obvious differences. With faster response times, we catch issues in their early stages, and there's even more than meets the eye there. Just for the sake of example, let's say both of these, Asset X and Asset Y, let's say they were both experienced misalignment cases. So Facility 1 with Asset X was able to resolve their issue in a very timely manner. They had a 10-day turnaround time and a 4-day turnaround time. So they've minimized the damages and they've optimized the performance of the machine. In Facility 2, if they've let their machine run for an extended period of time under a misaligned condition, they'll most have certainly experienced increased energy consumption, which leads to greater emission. And they probably have potentially ate through more resources like couplings or sheaves, belts, bearings, seals. And they've probably greatly reduced the longevity of their machines. In this slide, we'll be showing some other things that we track in the AssetWatch software. This is also a comparison between two customers. We track assets, alerts by component type. So is it your motors that are giving you fits each time, or is it a high percentage of your alerts are fan issues, gearbox issues, and so on? And then we also track alerts by fault type. So when we're looking at data, when we come to a resolution, we tag that with what the issue was. And this can give you real insight. So is it imbalance that you're having issues with, misalignment, bearing trouble, looseness issues? Well, there's a lot to take away from this. Well, customer A, I know this slide's a little bit hard to read, but customer A over here has virtually no misalignment faults. They have just a few, looks like maybe 4%, compared to 15% misalignment faults at customer B. So this may raise some questions on if you're doing your alignments in-house. You may want to question if you need to get more training for your maintenance teams. If you're using a vendor to do your alignments, maybe you want to assess how well that vendor is doing on your alignment jobs. Over here on component types, customer B is having 66% of their issues related to their motors. And that's only 35% at customer A. So this may lead to questions on, how well is the motor repair shops that we're using doing on our motors, or, how well are we, what routines do we have in cleaning our motors, or things like that. So definitely some eye-opening trends can be spotted here. And in both graphs, you see that they have some reoccurring bearing issues, which is the green bar graph there. So in both sites, they could probably do some things to optimize their lubrication program. So let's summarize our key takeaways here. The goal isn't just to collect KPIs, it's to use that data to understand behaviors and barriers. It's to drive change by connecting these insights to real world action. Every plant is different. Cultures, process, pain points, they're all different in each facility. So we want to look at that real world data, that real world fault trends, instead of going with the gut feels or schedules to optimize our processes and guide our teams where they need to be. Predictive maintenance doesn't just help find faults, it helps us highlight areas where we can improve. So, looks like that's the end of our slides. First of all, I would like to thank everybody once again for your time. As I said, I know how hard it can be to squeeze in things like this, so we sure appreciate your attendance. And I think at this point we can take some questions, and I'll pass it over to Adam so he can kind of host some of those.
Yeah, absolutely. And thank you, Dustin. Some great insights there, and I appreciate you sharing your experience with the audience. To kick off Q&A, I have a question of myself. So in your experience, what is the biggest roadblock you typically see when it comes to turning some of this asset level insight into action?
So here at AssetWatch, in particular, our biggest hurdle is getting that engagement from the customer, and what we see a lot of times is especially early on in our partnership, there's some drawback on communication and things like that, but it's very, very important. So we try to make it a point of how important this is and drive that engagement, because as we've seen in some of these examples, the quicker you're able to respond and start that troubleshooting process, that the communication back and forth, the quicker you can get these issues resolved. The only other roadblock that I could think of would be timing. Some facilities, their processes are very demanding and don't leave a whole lot of time for maintenance work. So trying to fit those maintenance activities into those time blocks is sometimes a challenge, but that's another beauty of predictive maintenance, is you get that early warning in most cases, and give you time to plan to get your spare parts on the shelf, and look at maybe your next outage coming up and be ready for that work when the time comes.
Excellent. No, thank you for that. We have a question from David in the audience here. It's kind of a two-parter. How are abnormalities detected? Is it based on the RMS and overall vibration level, or does it monitor certain frequency peaks or bands? And then the second question is, what about bearing failures that are usually better detected using envelope analysis?
So to answer the first part, when we partner with a company during the first 30 days of monitoring, we really do a lot of manual analysis. So we're looking at time waveforms, and we're looking at FFT data, looking at levels, trying to see if there are any faults present, after our initial install. We try to work through those things first. And then after the first 30 days, our machine learning algorithms and AI starts taking effect. So the software will kind of automatically baseline things. And then we've got an asset risk engines, what we call it. It's looking for rapid changes in all sorts of metrics, like acceleration RMS, acceleration peak to peak, crest factor, velocity, temperature. So if those algorithms detect over a certain percentage change in a pretty in a certain period, it's going to flag those and prioritize what our analysts are looking at. We also have some algorithms that are looking, some things take slower to trend up, And that's another algorithm that we use that alerts our analysts to something is over time is slowly creeping up. But once the algorithms detect these changes and our analyst is brought in front of our analysts, prioritized on their dashboard, it's their job to go in and look at the specific frequencies that are causing the change. Is it rotational speed that's increasing? And we've got triaxial sensors, so we can get data on all three planes, axes, and just like you would with a portable meter, we're digging into that data and seeing what's driving those changes, and then making prescriptive recommendations from that. That's one thing that I think that separates us from the pack, is we've got a very experienced team, and we rely heavily on each other. I mean, right now we're up to about 30 analysts on the vibration side. So if some analysts may come from a pump background, where most of my background's been with electric motors. We've got people that's been in paper mills and just all sorts of backgrounds. So if one of us is scratching our head on a certain problem, we've got 30 other category 3, category 4 analysts to throw it in front of and get their opinion. And that's pretty awesome to be able to tap into that experience. The second part of your question was around the early detection of bearing faults, enveloping and such. We do use some tools like that it's not in the software yet. We've kind of like beta testing it in the background. So that's something that we're going to continue to develop. Not sure when it'll be rolled out, but we are working with that a little bit in the back end of things. And from what we've seen, usually the acceleration RMS is a pretty good indicator. You can see changes. The trends are valuable information. When you're taking continuous readings, it doesn't take long for that trend to let you know that something's changing, and you can flag those issues early and then track it over time until it gets to a point where there's an action that's needed. So, hope I was able to fully answer that question.
I think so. Thank you for that. Adrian asked, what is the most effective way of summarizing these KPIs for a company with a lot of facilities to senior leadership, showing success of the program and gaps that may arise, such as increase in mean time to resolution?
So that's something that in the AssetWatch software, we have a tab that's kind of dedicated to those KPIs. So if you take somebody in upper management that may be responsible for, let's say, 15 or 20 facilities, they can look at these KPIs at each individual site and look at it in a comparative view. So, just like we compared the 2 facilities, somebody that's responsible for 15 or 20 facilities can look through and see their best performers. They can see the ones that they probably need to ask some questions. And then we also benchmark against over our whole customer base. We use the top 25% performers as a benchmark. So you can also, kind of see where you are as a company compared to some of the top performers in your sector, whether it be like forestry or pulp and paper or food and beverage, those sort of things. Hope that answers your question.
Excellent. This next one isn't a question, but I'm going to kind of turn it into one. So Kevin in the chat said, old school maintenance techs don't believe in these newfangled doodads, that they work as well. And I think that's a real challenge, right? Just building that trust. So how do you approach that yourself and with some of the folks that you work with, Dustin?
It's a very good point. And it's something that I've dealt with over the course of my career. You still get, it's just a matter of familiarity with it. Some people who have not gotten good knowledge of what you're actually doing, don't really see, they can't understand it. So, and still today, every facility is different. Every customer is different. We onboard some customers that's really far along in their maintenance journey. They're able to hit the ground running. They understand the importance of communication. But we still have those that are a little bit slower to come around to what we're doing. So it's one of those things that you got to prove that value out, and I think that we do a good job of that. It's no secret that we offer a 30-day trial, basically free, and that's what we try to do in that 30 days is catch those issues to those people that are a little bit slower to come around, to prove that to them. And it's just something that it takes time to evolve. I've had customers here at AssetWatch that told me up front that they were just going to use this system kind of as a break on their insurance, and they really wasn't interested in the data. But over time, we've had some big saves, some really high dollar saves that saved, from complete failures on very costly machines. And over time, they've become believers. They show up to every data review. If we create an alert, they're really quick to respond back. So I think it's one of those things you just got to nurture along, try to improve as you go.
Yeah, absolutely. And I know we only have a few more minutes here, and you've been providing great detailed answers, Dustin. So one more question to wrap things up. And for those of you we didn't get to, we will be following up. We'll send out the recording after the broadcast. You will be getting some outreach with more information and assets to look into as well from some members of our team. But to wrap things up here for the final question, how do you benchmark our prescriptive maintenance performance across multiple sites or plants to make sure there's that balance and insight?
Well, I kind of touched on this one briefly, answering another question, but if you've got multiple facilities, you can kind of do a comparison. You can even, if you've only got two facilities, you can look where you're at in relation to one another. What is facility A doing better than we are? What are we doing better than facility A? If you've got multiple facilities across your company, obviously you've got more data to pull from. You can look at some of your top performers, what they're doing good. You can communicate with them on their practices. And then if you're a standalone site, like I said, we do benchmark our top 25% performers in each sector. So, if you're in the mining and minerals sector, you can kind of see where you stand up against the top 25% in that sector. So I think that's the last question. So once again, I appreciate everybody's time, and let us know if you have any more questions. You can go to assetwatch.com. But if there's any additional questions, feel free to send it our way via email or however you want to do that.
Excellent. Thank you so much, Dustin, again, and thank you to everybody who joined us today. As Dustin mentioned, if you'd like to learn more, visit our website, assetwatch.com, or reply to the emails you'll be receiving shortly. I hope you took something of value away from this webinar. If you have any feedback, please let us know as well. Thank you again for attending, and we hope you enjoy the rest of your day.
Thank you.